the most challenging parts of calculus is deciding whether or not a limit actually exists. For limits that are of polynomial functions that are in nice form of, for example, x cubed plus 6x squared plus x minus 5, polynomial functions are easy to work with, and we will examine how to do those. However, there are certain situations that yield that a limit does not exist. First, the limit coming from the left does not equal the limit coming from the right. As an example, if we consider what happens as x gets really close to the value of 1 for x minus 1 divided by the absolute value of x minus 1. If you look at the graph here, as we come in from the left, the y value in each case is equal to -1. However, when we look at the y value when x is above 1, we have the y value, or f of x, is equal to +1. So if I was to ask you, what is it getting close to? As the graph gets close to 1, you say it's getting close to 1 up here and -1. Because these two values are different, we would have to say the limit does not exist. Which seems like a strange answer to a question, but it will happen more often in calculus than in other courses. Let's consider the second possibility, the existence of a vertical asymptote. If we have an equation and we have a vertical asymptote, this is usually found when you have a denominator that has a variable in it. If x plus 3 is in the denominator, we know we can't have a 0 in the denominator. Therefore, if we solve this equation for x equals -3. So in fact, x cannot take on a value of -3. So what happens as we take the y values here and we get closer and closer to x equal to -3 from the right hand side, we get a very, very large number. As a matter of fact, the number is so large we can't come up with a number for it. The other side, coming from the below -3, is going in the opposite direction. But even had they both been going in the same direction, because of the vertical asymptote, because the y value is so large that we can't write it down, we have to again say the limit does not exist. Finally, there's the situation where we have an oscillating behavior. And an example would be the limit of the cosine of 1 over x as x approaches 0. Now at first you might panic when you see 1 over 0, because you're not allowed to have a 0 in the denominator. However, since we're taking the limit, it's okay to do this. But the graph oscillates back and forth between two values, and it never settles down. And because of this, we call it oscillating, and again we say the limit does not exist.